Hello, and thanks for mathing with me today. In this video, we will identify and graph functions. The most basic function in a family of functions is called the parent function, and the graphs of each type of function have the same basic shape. So often, in order to graph any function correctly, we need to know its shape. Let's start by graphing a few parent functions. In the first function, we see f of x equals x. So we're going to create a table of values. I'm going to add -2, -1, 0, 1, 2 to our table, and then we're going to evaluate. So that means we plug in -2 to evaluate f of -2, and that's going to just equal -2. So -2, and then f of -1 would just be -1, f of 0 would be 0, f of 1 would be 1, and f of 2 would be 2. And now remember, we can convert this table into ordered pairs. So now we're going to go ahead and we're going to graph these ordered pairs on the graph. So to plot, I'm going to move to the left 2 and down 2 and plot -2, -2. Then I'm going to move to the left 1, down 1 to plot -1, -1. The point 0, 0 is just at the origin. I'm going to go right 1, up 1 to graph the point 1, 1. And I'm going to go right 2, up 2 to graph the point 2, 2. Then we're going to connect the graph with a straight line, and we're going to put arrows on the ends. Since we know the graph goes on forever and ever in both directions, because if we were to evaluate the function for any value of x, both negative and positive, we would get a value for y. So we see that this graph is a graph of a line. So this is a linear function, and all linear functions form lines when we graph them, so this graph's shape is a line. The next function says g of x equals the absolute value of x. So this is an absolute value function. So we're going to plug those same values in, -2, -1, 0, 1, 2. It's usually a good start to graphing these types of functions. We definitely want both negative and positive values in our domain. So when we plug in -2, g of -2 is the absolute value of -2. So if it helps, you can always plug in values and write it out and evaluate it. I find it easy to do in my head, but sometimes when you're first starting out, it's helpful to plug it in. So g of -2 is the absolute value of -2, which remember, absolute value function takes any value and makes it positive. So g of -2 is positive 2. G of -1 then would be positive 1. G of 0 is just going to be 0. G of 1 is also going to be positive 1. And G of 2 is going to be positive 2. So let's go ahead and plot these on the graph. So we have the point -2, positive 2. And we have the point -1, positive 1. And we have the point 0, 0 at the origin. And the point 1, 1. And the point 2, 2. And we're going to go ahead and connect our points. Again, arrows on the ends of our graph, because this graph can go on forever and ever. We can plug in any negative or positive value in for x, and we will get a y value from it. So notice these absolute value graphs are going to be V-shaped. So all absolute value graphs are V-shaped. The last parent function we're going to graph today is h of x equals x squared. So we're going to plug those same values again into our table for our domain, -2, -1, 0, 1, and 2. And whatever we plug in, we are going to square. So something to remember when we square x is that x, all of x is being squared. So when we have h of -2, that equals the quantity -2 squared, which is going to be a positive 4. So -2 squared is positive 4. -1 squared is going to be -1 times -1, which is positive 1. 0 squared is just 0. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. So let's go ahead and plot these points. We have the point -2, positive 4. We have the point -1, positive 1. We have the point 0, 0. we have the point 1, 1, and we have the point 2, 4. When we connect these points, you'll notice that we will get a U-shaped graph. So these are called quadratic functions, and they are always U-shaped. So the information that we want to get from graphing these parent functions is the fact that linear functions are always lines or straight lines, right? So this is when we have f of x equals something like the form y equals mx plus b, or f of x equals mx plus b. X is to the power of 1. Absolute value graphs, such as g of x equals the absolute value of x, are always V-shaped, and functions where x is being squared, or a quantity including x is being squared, these functions are always U-shaped. Let's try graphing some other examples. Notice that these functions in numbers 1, 2, and 3 are all functions that are not parent functions. They have some sort of transformation on them. So they are similar functions to the parent functions that we had. For example, in number 1, we see that we have an absolute value function. So the first thing that I want you to do, now that we know the shapes of these types of graphs, is to identify the shape before you graph. Why is that? Because depending on the shape, sometimes if we are skewed or moved left, if the graph is moved left or right on the graph, we could graph part of it and it will look like a different shape. So we want to make sure that our graph is the correct shape, and you'll kind of see that especially in number 3 when we get there. In number 1, we're going to go ahead and still pick the same values that we picked before, -2, -1, 0, 1, 2. Once you start recognizing kind of the way these graphs transform, you will kind of be able to more easily pick the points that you're going to graph. However, in this particular example, when we're first learning, it's just helpful to pick points, see if it's the right shape, and then if it's not the right shape, pick more points to graph on the left side or right side of your graph based on what shape you know the graph should be. So let's talk about the shape of number 1. F of x equals the absolute value of x minus 3. So we learned in the previous examples that absolute value graphs are V-shaped. So we're going to write V-shaped up here, and then when we plug in our values, if our graph is not V-shaped, then we are going to plug in more values until we get a V-shaped graph. So first we're going to plug in -2. So we take the absolute value of -2, which is +2, and then we subtract 3. So 2 minus 3 is -1. When we plug in -1, the absolute value of -1 equals +1, and 1 minus 3 is -2. If I plug in 0 for x, the absolute value of 0 is just 0, and 0 minus 3 is -3. When I plug in 1, I get the absolute value of 1. 1 minus 3 is -2. And lastly, when I plug in 2, I get absolute value of 2 is 2. 2 minus 3 is -1. Now we'll go ahead and plot these on our coordinate plane. So we have -2, -1. We have -1, -2. We have 0, -3. And we have 1, -2. And we have 2, -1. Then we're going to connect those with a straight line with arrows on the ends. Remember that we can plug in any value for x, both negative and positive, so we need to draw arrows on the ends of our graph to signify that. Now let's identify our domain and range. So hopefully you watched my previous video on domain and range. If not, you might want to go back and watch that video to help you with domain and range. What we see here is that we have a continuous domain and range, so we cannot possibly list all the values of our domain or our range. Therefore, we will write our domain and range both in interval notation. And what I know first is that the lowest value of my domain, because this graph goes on forever and ever and ever in that direction, we know that the lowest value of our domain is going to be -infinity. And then the highest value, again, it goes to the right forever and ever and ever. So the highest value is also infinity. When we're looking at range, we want to look at the graph from the bottom to the top. So as we move up on the coordinate plane, we see that the graph starts at the value y equals -3. So we're going to write that our lowest value is -3. That gets a bracket because -3 is part of our graph. And then we see the arrows tell us that it goes on forever and ever. So our range is -3 to infinity. In the second example, g of x equals -2x plus 3. This is a linear graph, so the shape of our graph should be a line. So we're going to plug those same values in, -2, -1, 0, 1, 2. Later on in algebra, you will learn an easier way to graph this, but for the basics of graphing any function, you can always plug in values of x, evaluate the function for those values of x, and get an output of y and plot the points. So we're just starting out, so we're going to graph it by inputting points and writing our input outputs as points on the coordinate plane. So if I plug in -2, g of -2 equals -2 times -2, that's going to give us a +4. +4 plus 3 gives us 7. So again, if you need to write this down, right, to evaluate these, please do so on paper. You should always do that rather than making mistakes. -2, if g of -1, -2 times -1, that gives me a +2. +2 plus 3 gives me 5. If I plug in 0 for x, g of 0 is -2 times 0, which is 0. 0 plus 3 is 3. If I plug in 1, I get -2 times 1, which is -2. -2 plus 3 is +1. And lastly, if I plug in 2, I get -2 times +2. That's -4. -4 plus 3 is -1. Let's go ahead and plot these points on our coordinate plane. -2, 7. And -1, 5. 0, 3. 1, 1. And 2, -1. We can connect that with a straight line. We know that this graph is supposed to be a straight line, and we put arrows on the ends. So when we look at the domain of the function, that means all the values of x that are included. We see that the graph goes on forever and ever to the left and forever and ever to the right. So that means that the domain is all real numbers, and we write that as parenthesis, -infinity, comma, infinity, parenthesis. And then the range as well. If we come up from the bottom of the function, right, we see that there's an arrow here. That means this function goes on forever and ever and ever. Therefore, the range is also -infinity to +infinity. All right, our last function is h of x equals the quantity x minus 4 squared. So this function is a quadratic function. We see something is squared, which means that the shape is going to be U-shaped. So let's plug in our values again. And I'm going to plug these values in, and you're going to see that we have a problem here. So let's start with evaluating -2. So if I say h of -2, I'm plugging in -2 for x. I get -2 minus 4. -2 minus 4 is -6, and -6 squared is +36. So we are way off our graph here. What happens when we plug in -1? -1 minus 4 is -5. -5 squared, which is -5 times -5, is +25. We're still way off our graph. What about 0? 0 minus 4. -4 squared is +16. Still off our graph. Let's plug in 1. 1 minus 4 is -3. -3 squared is +9. Finally, a point that we can see on our graph. So notice that this graph we're gonna have to graph some more points to the right side. So we'll go ahead and plot the first two that we have. So let's plug in 2. 2 minus 4 is -2. -2 squared is +4. All right, so plotting those first 2 points, 1, 9, and 2, 4, that actually fit on our graph, we see that our graph is not U-shaped. So we need to graph some more points to the right side of the graph. So we're going to go ahead and plug in a couple more values. We're going to plug in 3, 4, and 5. So let's go ahead and fill in the rest of our table. Plugging in 3, we get h of 3 is 3 minus 4 quantity squared. 3 minus 4 is negative 1. Negative 1 squared is 1. Plugging in 4. 4 minus 4 is 0. 0 squared is 0. 5. 5 minus 4 is 1. 1 squared is 1. All right, we can plug in 6 and 7 as well. So if I plug in 6, 6 minus 4 is 2. 2 squared is 4. And lastly, 7. H of 7 is 7 minus 4, which is 3. 3 squared is 9. So notice when I plot those points that we have a U-shaped graph. So let's go ahead and connect our points. And then don't forget to put arrows on the ends. And we have a U-shaped graph. So really, we could have just evaluated for these points in our table. And essentially, if we only wanted the 5, we could leave off the last 2, but it's nice to fill your graph. You really get the full U-shaped graph, but at minimum, we should be graphing 5 points. I like to say graph all the points that fit on the graph. Now let's talk about our domain. Again, in this function, we see that the graph, we could have plugged any values of x in, negative or positive, so our domain is going to be negative infinity to positive infinity. And our range, as we come up from the bottom of the graph, we see that it starts at 0. It includes the point 0, so it gets a square bracket, and then it goes to infinity. Those arrows tell us it goes on forever and ever and ever. All right, now it's your turn to try. Pause the video and try number 1. Hopefully you paused the video and you saw that f of x equals absolute value of x plus 1 is a absolute value graph, which are V-shaped. And when you plug in negative 2, negative 1, 0, 1, 2, you get a V-shaped graph that has the domain of negative infinity to infinity and the range of 1 to infinity. Try number 2 on your own. Pause the video and try number 2. Hopefully you paused the video and you found that the shape of g of x is a line. And therefore, one thing that I did differently here in this graph is notice that the x values are all going to be multiplied by 1/2 or divided by 2. Therefore, I chose values in my table that divide evenly by 2 so that I would have nice integer points. This is always a good strategy to adjust the values that you plug in order to make it easier to graph integer values. So when I did that, I got a line, and my domain and range are both all real numbers. Pause the video and try the last problem. H of x equals the quantity x plus 2 squared. Hopefully you paused the video and you found that the graph is a U-shaped graph, which you should identify first, because if you plugged in the values negative 2, negative 1, 0, 1, 2, you'll notice that you're going to get a graph that's skewed. And so you really need to consider that you're adding 2 to the values. So if we want to get negative 3 in here, which is the value that I want to get because I know that 9 fits on the graph, and when I square negative 3, I'll get 9, then we need to adjust the value that we plug in. So the first value I chose to plug in is negative 5. If I had started at negative 2, notice that I would have only had this half of the graph, which is not U-shaped, right? It's like a half of a U. So we need to plug in these 3 values in addition to those values so that we can get this half of the graph as well and get our full U-shaped graph. When we do so, we get the domain of all real numbers and the range of 0 to infinity. So hopefully you learned a little bit about graphing functions today. You will definitely learn some more valuable strategies for graphing these types of functions later on in algebra. However, this is a good rule of thumb, is that you can always plug in values of x and get values of y, plot those coordinates on the coordinate plane to graph. Thanks so much for mathing with me today.